In this video, we're going to look at prime factor decomposition, which sounds a lot worse than it is. A lot of times, students know this as the cherry trees. Okay, and as soon as you say cherry trees, people go, oh yeah, I know exactly what to do. So I guess the first bit of knowledge and study that you need to do is, when do I do the cherry trees? And if you're not too sure what cherry trees are, you'll see that in a minute. But essentially, you will see a question that kind of looks like this. Express 120 as a product of its prime factors. This is what a question like this usually looks like. So essentially, your study and your revision isn't to do thousands of these cherry trees and thousands of these breakdowns. It's more learning that when I see this, I do the cherry trees, because I talk to a lot of students. They see a question like this and they go, what do I do? I say, oh, this is a cherry tree question, and they go straight off and do it. But that little gap of when to use that skill is the bit that's missing. They know what to do, just not when to do it. So with your study, create a flashcard with a question like this, and you say, if you see express, it doesn't necessarily have express at the front, but often it does. You see product, which means times, and then factors, numbers that will divide without a remainder, and prime. You need to know the first few prime numbers. 2, 3, 5, 7 are the most common. And these are numbers that only have two factors, one in itself, but one is not a prime number because it has to have, the definition is two factors. So one doesn't count. The first one is 2, and 2 is the only even prime number. So every other even number is not prime. Okay, if you're doing this on the calculator, we can do 120 equals and then shift fact. So the factors, the prime factor decomposition, can be done on the calculator like this. This is the final answer that you're looking for. So I'm just going to write that to one side. 120 equals 2 cubed times 3 times 5, because that is our end goal. We start with 120. And we're looking for numbers that times to give 120. You can choose any pairs you like, 12 and 10, 3 and 40, whatever. But most people will go with 2. And when you hit a prime number, you put a circle around it. And it starts to look a bit like cherries. So that's where the name comes from. So 2 goes with 60. So 2 times 60 gives 120. If you're ever unsure, you'll have to do 120 divided by 2 on your calculator or bus stop, whatever method you want to use. 60, that's even. So we can keep using 2 until we run out of even numbers. 2 goes with 30, 2 times 30. Keep going. 30 is still even, so 2. Circle that, and we have 15. 15 is not even now, so we can leave the 2's. We can go to the next prime, which is 3. Does 3 go into 15? Yes. 3 pairs with 5. And we've kind of reached the end of the branch because we've done 3 times 5 to give 15. So this is our completed cherry tree. Students will often do this and go, yeah, I'm done now, but you haven't actually answered the question yet, because we have to express 120 as product multiply. Multiply all your cherries together and you've multiplied all the prime factors. So 2, another 2, another 2, a 3 and a 5. Like that. Okay. So this would be most of the way there. We've got some duplicates here. 2 times 2 times 2. We have to show that as 2 cubed from our indices work. And the 3 and the 5, there's no duplicates there. So That's our finished cherry tree. Okay, let's do one more example. Let's do 150. I'm going to get the answer straight away off my calculator first, because this gives me the framework for my cherries, because I know I need a 2 first, like that. That would go with 75, so 2 times 75. And then I can look at my cherry and I can see I need 3 next. So 75 divided by 3 is 25, and then 5 squared, yeah, that works, 5 and 5. Okay, so we start to express this as products of the cherries, 2, 3, 5, and 5. There's my 4 cherries, and then the duplicates, I've got 5 squared, and that matches my answer exactly. Okay, so as soon as you see this weird wording, express 120 as a product of its prime factors, if you learn, when I see this, I do cherry trees, you'll probably be able to do the cherries correctly. And if you can remember to pop this on the end, then you've fully completed the question.